Hi everyone, in today's lesson from Unit 3.1, we're going to be looking at something called a special right triangle. So there are some right triangles that have a special relationship between their sides. Look at the triangle below. It says that we're given that the measure of angle A is equal to 45 degrees. So let's put 45 in there. It says, how can you find the measure of angle B? Well, remember that the three angles in a triangle add up to 180 degrees. So if we take 180, subtract 90 from it, for a right angle, we get 90 degrees. And if we subtract that 45 degrees that we're given for angle A, that would leave us with 45 degrees for the measure of angle B. Okay, next thing, we should notice that angle A and angle B are congruent. So this tells us the triangle ABC is isosceles. Because if two angles of the triangle are congruent, then the sides opposite those angles are congruent. So since triangle ABC is an isosceles triangle, we can say two sides are congruent. In other words, AC is congruent to BC. You can go ahead and mark that in your diagram too. So next, we're going to investigate the relationship between the sides, the legs of the right triangle, ABC, and the hypotenuse. So whenever you draw the picture, you guys have your worksheet so you can still see it at the top there. But if we know that these two angles are each 45 degrees, then we know that the sides opposite those angles are congruent. So if we're given that AC equals 1, then we know that BC has to be 1. And now we can solve for the length of side AB. We're going to do this by using the Pythagorean theorem, but to make it a little bit easier, let's just let AB equal x for now. So now that we have the three sides labeled, let's use the Pythagorean theorem to solve for x. So we've got 1 squared plus 1 squared is equal to x squared. Now 1 squared is equal to 1, of course, so we have 1 plus 1 equals x squared, or 2 is equal to x squared. We want to take and solve for x, so we need to take the square root of both sides. So we have the square root of 2 equals the square root of x squared. That's going to give us x equals the square root of 2. So the sides are 1, 1, square root of 2. 1, 1, square root of 2. Well, let's take a look at another triangle and see what happens with the sides in that triangle. Okay, so as we saw in the last piece, if these two sides are congruent, we're going to say they have the same measure, so 2, 2, and let's call this side x. So let's solve for x by using the Pythagorean theorem. 2 squared plus 2 squared equals x squared. So 4 plus 4 equals x squared. 8 is equal to x squared. And now the next step, we take the square root of both sides in order to solve for just x. So the square root of x squared is just x, but we have to simplify the square root of 8. Remember, we do this by looking for a perfect square that divides into 8. So we want to factor 8 into 4 times 2. The square root of 4 gives us 2 square root of 2. Alright, so we found out that our hypotenuse in this case was equal to 2 square root of 2. So let's put that right here, 2 square root of 2. Alright, let's try it one more time. In our next triangle, if this angle is 45 degrees here, that leaves us with 45 degrees for this angle. So the sides opposite those two congruent angles have to be congruent. So line segment YZ also has to be 5. And let's solve for this side right here. Let's call it y this time. So I'm going to do 5 squared plus 5 squared equals y squared. 5 squared is 25 plus 25 equals y squared. Add them together, we get 50 is equal to y squared. and then take the square root of both sides. When you simplify the square root in this case, we want to factor it into 25 times 2. Square root of y squared would give us y. Take the square root of 25 and get 5 out in front, 2 inside the radical. So 5 square root of 2. Right, 5 square root of 2. So check this out. In this first example, we had legs of length 2, 2. Hypotenuse was 2 square root of 2. In our second example, the legs are 5, 5. Hypotenuse was 5 square root of 2. The first example that we did, it was 1 and 1 for the legs, and the hypotenuse was 1 square root of 2. So it says, describe any similarities in the examples above. Well, we can say that the hypotenuse is the square root of 2 times the length of the leg. Okay, so if we break it down very simply, the general relationship for 45, 45, 90 triangle is as follows. The sides opposite the 45-degree angles we're going to label with x. And to find the hypotenuse, you take the length of the leg and you multiply by the square root of 2. So you can say it goes x, x, x square root of 2. So you can use this relationship to quickly solve for the missing lengths of a 45, 45, 90 triangle without using the Pythagorean theorem. Although, if you got stuck, the Pythagorean theorem is going to be your backup plan. Okay, we're going to try a few examples. So remember that it goes x, x, x times the square root of 2. So again, in a 45, 45 right triangle, which we have here, so these two angles will be congruent, the two legs are going to be the same, and you find the hypotenuse by taking the leg and multiplying by the square root of 2. Easy. Alright, and number 2, it's a little different because we have the square root of 3 in here. So label the sides first, this might help you. The two legs are each going to be 45, or the two angles are 45 degrees. So the legs are each labeled with x and x. Then the hypotenuse is x times the square root of 2. Okay, so x is equal to the square root of 3. So this side must be equal to the square root of 3 as well. And to find the hypotenuse, we're going to plug this in. We're going to plug in the square root of 3 in place of x. So the hypotenuse would be equal to the square root of 3. That's going in there for x, times the square root of 2. And when you simplify it, you get the square root of 6. And that's done. You can't do anything else with it. So the sides in this triangle go square root of 3, square root of 3, square root of 6. Again, we're still following the same rule. You take the leg, multiply by the square root of 2 to find the hypotenuse. Okay, now we're taking it up another level in difficulty. I'm still working with the same type of triangle. So we've got a 45, 45 right triangle. These two sides are congruent. So label those with x and x. And remember that the hypotenuse, that's the side opposite the 90-degree angle, right? That would be equal to the length of the leg times the square root of 2. So we have our sides labeled x, x, x square root of 2. And this right here gives us a little equation to solve. So if you're working backwards from the hypotenuse, we know the hypotenuse, we want to know the length of the leg, you divide the hypotenuse by the square root of 2. So divide both sides of the equation by the square root of 2. It's going to simplify and tell you that x is equal to 10. So each of these legs has to be equal to 10. So again, notice how it follows the pattern. 10 and 10 for the legs, 10 square root of 2 for the hypotenuse. Okay, so we want to divide by the square root of 2 to find the leg. Okay, one more. Still working with this 45, 45 right triangle, so these two legs would each be x. The hypotenuse is found by taking the leg and multiplying by the square root of 2. So again, to work backwards, we're going to follow this right here. We're going to divide the hypotenuse by the square root of 2. So the square root of 8 equals x square root of 2. Divide by the square root of 2 on both sides of your equation. And remember, when working with radicals, we can rewrite this as the square root of 8 over 2. That's going to give us the square root of 4, because 8 divided by 2 is 4. And the square root of 4 is simply 2. So each leg in here is equal to 2. Okay, next, try the CYU. Check your answers with a partner and also with a key, and then get started on your homework. Good luck!